Hey everybody, I hope you're doing well. I've only had one question this week about fixed axis rotation, so we'll look at that problem, which I think is a good problem to kind of conceptualize what's going on. So I created a couple little videos. I'm not going to work through the math, we'll talk about it, but it should be pretty straightforward after I describe this. So the problem is we have a disc with a diameter of 1 rests on a table. A second disc, diameter 2, is placed at the rim touching the first disc as seen in this figure. And we're going to hold this inner disc and we're going to rotate disc 2 around the outside of disc 1. And we're told that the diameter of disc 1 is the same as diameter of disc 2. It's just multiplied by 1. And we want to know how many revolutions our disc 2 is going to make, some point of that's going to make around the edge of this. So we know if the circumference is the same on both of these, we could think of the translational motion by some point. If we look at some point on a disc and we roll it, and so these two marks on the tape I've measured out to be the circumference of this wheel. And so when we roll this disc, we'll see if we just follow this black mark on the edge that it's starting at the bottom, it's coming up, it's rolling around, and then after we roll one circumference of this disc, we get one rotation. So it might appear at first that this answer's the answer to this would be 1 because we're just rotating around a disc that has the same circumference. But what we need to think about is what's happening, how we're rotating it. So instead of having this translational motion, if we think of a point where I'm going to have my finger here, I'm treating it as basically a point to rotate around a cylinder. I'm pretending that it's got basically a 0 diameter, my finger. It does have some diameter, so this won't work out perfectly. But you'll see when we rotate around this, my finger's basically touching the same spot. It should be touching the same spot as it goes around, but we still see that black mark on the edge of the disc that's rotating around, right? It's gone totally around. Let's watch that again. And so it should start to become clear that we need to consider both how it's rotating around and the surface it's rolling over. So when we combine these two, we put the two discs together. You could see in this video that I'm starting with the point up here. As we get a quarter of the way around, or let's say, I'm going to pause it here, we're halfway around this disc and we see that we've already rotated once. So by the time we get all the way around, we'll have had a second rotation. And so what it turns out to be in this problem is it's not just going to double with each of these. What's happening is we're going from the translational, if we're going to get however many rotations over this distance. In this case, it's just 1, but let's say the diameter that we were going around was twice that, we would have 2 rotations because our second disc would have twice the length circumference as this one. But then we also have to add the idea of rotating the disc in this manner. We need to add 1 revolution. So if the diameter is the same for both of them, we find that the rotation is going to be 2. But let's say you're given a value that in the problem that is different from the two diameters are different. Let's say that diameter 1 was 2 times diameter 2. Well, we know that we would rotate twice rolling over the surface, but we still have to add that 1 rotation because of how we're pivoting around this object and holding it. So hopefully that clarifies that. Let me know if you guys got any more questions, and I'll be posting more videos soon.